Four identical disks A, B, C, and D each rotate with initial angular speed omega naught in the counterclockwise direction. Different torques tau that vary as functions of time t are exerted on each disk from t equals to 0 to t equals to t final. Considering counterclockwise to be the direction of positive torque, which disk will have the greatest angular speed at time tf. First, we have to note that they are four identical disks, so rotational inertia for all four disks will be the same. Note that t equals to I alpha, and because we know that the rotational inertia for all four disks are the same because they are identical, we can disregard this. Now, to find angular speed, which is omega, we have to integrate both sides. And we have to do it with respect to t. Hence, if we look at the graphs A, B, C, and D, we have to find the areas under the curve for each one because this is a graph with y-axis as torque and x-axis as time. That is why we can use this formula. If the x-axis was theta, we would not be able to use this formula. Let's look at A. In A is a graph that is basically just 2 sine of theta. You will notice that both areas under the curve cancel each other out. In part B, you notice that there's a really small area under the curve because it mostly cancels itself out, but at the end of the day, oh well. Part C, it's a really large area under the curve. That's why it is the correct answer. But let's look at part D. Part D has a negative area under the curve. It will be a negative value, hence this will be wrong. And you will note from calculating the area under the curves for each graph that the correct answer is C.